am excited to introduce Jennifer Rahn, an expert I'm sure many of you are familiar with. Jen learned to dive on Saba, worked as a dive master at Saba with Lynn, and then returned to the States to pursue a doctoral degree in coastal geomorphology. Jen is now a geography professor and director of environmental studies program at Samford University in Alabama. That's right, y'all. There are 3 girls from Alabama on the island we're taking over.
One guy from Alabama.
Yeah, one guy. There we go. Jen has spent the past summer working on several projects on Saba, one of which we will hear about tonight. Please give a warm Sea&Learn welcome to Dr. Jennifer Rahn. Can you hear me? Is it good? All right. Lynn doesn't know this, but we're playing a drinking game tonight. Whenever a loud motorcycle or car goes by, everybody has to drink. Okay? Because you won't be able to hear me. So. All right. Leslie mentioned I'm from Samford University, and this is in the heart of Alabama. I wanted to show you guys who aren't familiar with the United States, where Alabama was. Roll Tide.
Roll Tide.
We're near the Gulf Coast. And next slide. I work in a geography department, and I teach, you should drink. No. I teach classes about geosciences and mapping techniques. And Lynn, you should be glad to know this is a picture from our last trip, last January, is on our homepage for the geography department. Next slide. And I do a lot of my research on Saba. I've been doing research here actively since 2008. And I'm going to be talking to you about a tent reef project that I'm beginning to work on. And then at the end, I'm going to mention a couple other projects that I'm working on. All right, so for those of you that don't know where Tent Reef is, or just to give you an idea of the location, here's Saba, airport's over here, Fort May's over here, Tent Beach, Tent Reef are in this corner of Saba. It says, and I took lots of images from the internet, so if you've posted anything on the internet, I'm probably using your stuff if it has any relation to Tent Reef, so thank you everybody for your Facebook photos. And many people donated photos. I can't thank everybody, but thank you so much for your photos. So this is a great aerial shot of Fort Bay. Here's a Fort Bay Road. And the area I'm talking about is over here, the tent area. And this is the Google Earth image showing you what tent looks like. So again, here's Fort Bay. There's a road that goes along the coast here. And this is the area we're talking about. Anybody know why it's called tent? Yeah, you can't see it if you're on the road on the land. We were walking there with some students and they asked, why is it called tent? But there's a little rock formation up here that looks like a tent. Next slide. And in the right sunlight, it's bright red or orangish red, and that's what the area is named for, that little tent. This is what's there. We have, if you were at my talk last year, we talked about the beaches on Saba, and that everybody thinks there's only one beach on Saba, but technically any mobile sediment along a coastline is a beach. And this is the beach we have at Tent, and you can see this in several other places on Saba. There's these nice rocky round cobbles along the beach, so this is technically a beach, although it's not one you typically want to hang out on, but it's a beautiful, gorgeous rocky beach. There's a lot of living things on the coast. These are intertidal organisms, crabs, mollusks, snails, all sorts of things grow in this environment. But the real big thing that's important about this area is the diving. And this is a map showing Saba. Again, here's Fort Bay. All these little hamburger things are dive sites. These are some of the premier dive sites right off the tent area. And another reason why this area is important, not only are there dive sites there, but most of the dives that our divers do are on tent. From 94 to 2009, on average, it was about 20% of all dives, and we just got the latest data. Thank you. Where's Eveline in the back? This last year, 2012, it was 26% of all dives done on Saba were done at tent. So a quarter of all dives are done in that area. All right, I'm first going to talk about a little bit about the geology and geomorphic history of the area, and then we'll talk about some of the fish that live there. So this is a really complicated graph, but basically it's showing you years before present. So this is 1,000 years, 2,000, 3,000, 4,000, 5,000. Oh, sorry, 100,000 years. Saba was underwater until 500,000 years ago. Then it came up as a volcano. But what I want you to notice is that sea level changes all the time. Slowly but surely, in geologic time, it changes. Click it once. This is where we currently are. Sea level has been higher in the last 5,000 years, and it's also been much lower. Next slide. Oh, here's the lowest sea level stand. This is an image from Stuart Chipka's orchid book. Anybody have that orchid book? He used this nice little map to show this is the current outline of Saba, and at the lowest sea level stand, this is how big Saba would have been. So when sea level drops, more land is exposed. So you have different areas that you can see. Next slide. So what happened in Tent in particular, here's the coastline, here's the beach, and then the reef is underwater here. And I'll show you some images in a second. But basically we had a sea level about let's say, this is from Tom Van Hoff's book. Sea level about this height, cobble beach forms here. There's also some cobbles and some sand forming offshore. Then sea level drops down, and you have probably what happened was there was a sandy area. If anybody's dove Tent or past the reef, there's a big sandy area. There was some kind of beach here as well, including cobbles. And then sea level came back up again. Presently is forming this cobble beach, but it left the remains of the cobble beach, the previous cobble beach from a low sea level stand. And the reef formed at this time when the sea level was lower. And we're going to see the reef comes out and has a wall, and pieces of this wall have actually fallen off. Large, giant boulders have fallen off in that area. All right, so this is the Tent area. This is where I typically do my research. I'm looking at the Tent beaches over time to see how do they respond to sea level rise, storms, etc. I have 13 permanent marked areas where I look at the slope at each one of these locations. The predominant current direction is going this way, and these are all the dive sites. But if you went from shore, that nice rocky pebble beach we saw, you would see that beach go underwater to about 10-foot depth, and then you hit a big sandy area that goes for, I don't know, 100 meters. Where's Jeff? He swam this with me. 100 meters, sand, and then you hit the reef. And I'll show you a close-up of this, but underneath the reef, you'll see cobbles. You'll see an ancient beach that the reef was built on top of. Next slide. So here's when you hit the reef itself, so this is all coral forming, and underneath it is cobbles. Next slide. And again, just another shot, that big sandy area, you'll see some cobbles, and you'll see the reef that's built on top of a previous coastline, a previous cobble beach. This is, and I'll show you a couple other maps, I'm not sure who drew the other ones, but Kat drew this one. And this is basically showing you a bird's eye view looking down. Here's that sandy area, beaches back there. Here's Tent Reef, the reef that actually formed and grew during the low level sea level stand. And then these are some of the boulders that have broken off that wall. And this is where we do a lot of our diving. And then here is a sheer wall that drops, I don't know, hundreds of feet at the deepest part. Next slide. If you've been on some of the boats, you may see some maps like this, or they'll draw it when you're about to go to a dive site. Anybody claim credit for this map? Rachel did this map? So here's Tent Reef. Here's the top of it, about 15 feet. Here's a boulder that fell over. There's a swim through. Here's a nice little cliff. And the wall or cliff goes on, and all these rocks and rubble are a little bit further offshore. And this is one of the fun parts of the Tent Reef dive. You can go underneath this overhang. And here's, I don't know who this is, Lynn? What, a famous Sea Saba diver diving on Tent Reef in this beautiful area. And another one, this is a little further down on Tent Reef, showing you this wall. Here's the top of it, which is shallower, and then that wall gets deeper and deeper as you go further west. Some other things that we see along the walls and ledges, lots of sea life, lots of fish. Recently, there's been some really nice seahorses here, and I heard they're pretty big. I haven't seen one yet, but no. Another little yellow sealers. Anybody know what this one is?
Frogfish.
Frogfish.
Long-lure frogfish.
But it's hard to see. They blend in with the surrounding area, usually a sponge. So here's the fish itself. His fin, his tail's back here. He kind of sits there like this. And this is a nice video that I got from Lynn, just showing you, wait, before you started. Is anybody, who doesn't dive? Who has never been underwater? Okay, there's a couple people. When I was talking, when I was doing some of my research this week with some of the kids on the island, they didn't know why it was named tent, so I explained that to them, although we couldn't see the tent from land. And then they've never seen what it looks like underwater. So for people who don't dive, I wanted you to see the exquisite beauty and the sea life that we see underwater. Grouper. And you can see he's swimming over the cobbles, the ancient cobble beach that the reef was formed on. I keep calling out the fish.
Strong fish. Black Durgan. Blue Croby.
Brown cone. You see a lot of turtles in this area, and I've seen them.
Fish.
Yes, I've seen little tiny turtles and big giant turtles, so they come in all sizes. So this is the swell moving back and forth. You can see some of the sea fans, some of the gorgonians moving as the turtles moving with the surge.
He doesn't even know it's a marine park. You're not supposed to touch stuff.
Again, this is under the overhang, one of the smaller walls. So we have lots of life, lots of color. It's one of the reasons why this is one of the most popular dive sites, because there's so much to see here. I think always you see 100 really cool things. Yeah, you don't want to touch that one. Nice angelfish. Turtles. Turtles are usually on the top feeding and grazing. Yep. Is it a boy or a girl? Okay, that's the beginning of it. All right, so this area has fantastic sea life, some of the best sea life in the world, which is one of the reasons why Saba is so famous as a dive area. I'll talk more about this a little bit later, but I wanted to show you this mapping context. So this is the current marine park map that's showing you depths in 10-meter contour lines. So each one of these is 10, 20, 30, 40, 50 meters. One of the projects I'm working on this summer is to do this mapping at a higher resolution, and this is one of the current maps I have. You can go to the next slide. And then in some of the programs I have, I use a geographic information system. It's not hooked up to this computer, but you can swivel it around and look at it in 3D. So this is looking, Fort Bay's over here, looking to the west. And the next slide, now we're down at the end of Tent looking back towards Fort Bay. So it drops off pretty quickly into the deep sea. All right, so the title of this talk is Tenuous Tent Reef. And the reason why the reef may be in trouble is because of some things. There's a lot of stress going on reefs right now, global warming, climate change, a whole host of different things. So reefs are kind of under stress more than they've ever been before, but now we're adding another stress that people on the island could possibly be stressing this reef. So again, this is the area, and the area I'm talking about, if you've been down there recently, is going to be this area right here, the beginning of that road. Again, Fort Bay is over here. Next slide. So we talked about how this is a nice, beautiful cobble beach, naturally. But at some point in time, about 3 years ago, people started considering this area a dump. And they were dumping things. This had been here a long time, some kind of big tank. Next slide. Cars, tires. They just, I don't know why, but they didn't want to take the stuff to the actual dump, so they started placing a lot of really not so good stuff on the coast. Next slide. Cement, a lot of the road was dumped here, a lot of rebar in the cement, stuff that didn't look very pretty. And soon, this was from 2011, they were dumping all this kind of on the top, and didn't take very long for this stuff to reach the actual shore. So it's getting reworked by the waves. That cement, that rebar, anything else they've dumped will soon be on the beach, and eventually, if there's big enough waves, would be on the reef. The other thing that's happening besides, and they've cleaned most of that up, if you've been down there and seen the changes in the last year, they've cleaned kind of most of the other trash that was on the island, but there's another thing that's a possible threat to Tent, and it is the rebuilding of the buildings in this area for fishermen. Did someone say something? Okay. So they started digging in this area and taking all this sediment away. And this was the beginning of building those things, but they removed pretty much this whole hillside. And they dumped it on Tent. It was a nice, easy location to put it at. This is Lynn sending me a picture to let me know what was going on in the area. And I just took this the other day. This is the whole area that was excavated, that they put that fill, we're calling it tent fill, on the beach. And it's a minimum of 3,000 dump trucks. It's a lot of material. So one of the things I did was go through and compare. It pretty much started the massive dumping, this 3,000 truckloads started around 2011. So you can see there was a nice road. If you remember, if you've been down there, you can see a nice road that was pretty close to sea level. It went uphill a little bit, and now it's just a sheer slope of sediment from the fishermen's sheds. Next slide. So again, we had a nice level road that was close to sea level, and this is probably 15 meters high of sediment, 200 meters long. Again, there was nothing here in 2011. The natural slope of the land came down, and now we have this big chunk of loose clay sediment. And another picture, and I tried to get these in about the same location. There wasn't much here. Sometimes a beach actually forms on Tent. Small little areas of sandy beach will form, and now this is what it looks like with that. It's a really orangey colored sediment. All right, so we have this nice, wonderful cobble beach. Next slide. Now we have this big wedge of sediment, and there's a couple problems with this sediment. Next slide. From the land, and if you guys go by, some of you that are divers, if you go by on the boat, it doesn't look that big, but it is a large volume of sand. Next slide. This is what it looks like from the boat. It pretty much starts, if you walk down the road where the last big boulders stop, and it goes all the way until the road dips down again. So this is that 3,000 truckloads of sediment. You can see some of the natural coastline is still left. All right, so here's all the fill. And we're going to start talking about the implications of what that fill is made out of. In April 2011, I was asked by the Marine Park to put together a report on the implications of the concrete that was being dumped there and the soil fill. And then in August of 2012, I wrote another report that the Conservation Foundation submitted to the government on the sediments in relation to dumping on Tent Reef. So the dump soil is a distinctly different geology than the natural soil that's there on the slopes. And we'll see that the grain size, or the size of the sediments, is different than what's naturally there. And it was loosely compacted. It's slowly getting more and more compacted over time. And these clay-sized particles form a very steep slope. We went out and measured it, and it's about a 30-degree slope. So this is a geology map. Here's Fort Bay. This is the material that they took. You can see some of it's naturally occurring here, but it's not the natural type of sediment that's here. And we'll talk more about the implications of that particular sediment in a sec. So last year we talked about where's the beach grain size. When we look at the sediments on a beach, we look at how big they are. So boulders are 265 millimeters and up. Then the next smallest down we call cobble. Then we have pebbles, sand, silt, and clay are the smallest, finest particles. And we've done some experiments with, this is the tent fill, this is Wells Bay sand, and this is sand from St. Martin, and we did a couple experiments with some other sizes. Next thing. One of the things you can do is see how fast water runs through these materials, because that'll give you an idea of how saturated the soil will get. So we did this in, I did this for last year, Sea&Learn, with some of the students in the comprehensive school. And they timed how fast the water went in and how much each type of sediment the water would hold, because this gives you an idea of the stability of the soil. And then another thing you can do is put the soil in water to get an idea of what will happen with that sediment once it gets in the water column. So the smaller particles will stay suspended a lot longer than large particles. So if you have a jar like this with sand, silt, and clay, and you shake it up, the heaviest, biggest particles, the sand will fall out first, and the silt and clay will stay suspended. Some of it will fall out immediately, some of it will stay suspended for a while. So next slide. And where's Shadon? Did he leave? I told him he was in here. So I worked with Shadon also last summer looking at sediment settling velocities, and porosity, how long it takes. And one of the things I also did with kids is, so we have a jar, and this is regular Wells Bay beach sand, and you just shake it up. And most of the sand's a little hard to see. Most of the sand falls out immediately. There's some smaller particles that stay suspended for a little while, but this will clear out in a couple minutes. This is the natural beach sand on Saba. With the tent fill, we see something significantly different when we shake it. First of all, it's hard to get off. It's clay, so you've played with clay, and it's very sticky, and it holds together really well. But when you shake it up, it doesn't settle immediately, and this particular sediment will take a long time to settle. Next slide. As a matter of fact, we timed it in 2011. By the time a cylinder like this became clear, it was 5 hours later. This is totally still water. This is with no waves or anything. 5 hours for this sediment to clear. Again, we also measured the slope initially, just to figure out how steep it was. The other thing with this clay material is that it gets packed together and it gets a little wet and it can start cracking. I don't know if you ever see clay crack when it dries. So we started seeing lots of big cracks along the top of the fill area, and this makes it very unstable and it could collapse. And you can have a landslide, so that stuff would fall immediately right next to the shore. Just showing you, there is some pebbles and stuff in there, but as the clay dries out, it does make those big cracks. And there's a variety of ways, and you can see some of them on, and I'll show some pictures in a minute, of what's happening there. So it can kind of rotate and slump down. We see a little bit of that. You can have some sheet flow flowing down. And then the thing that we really see in this particular area is rills and gullies, so like little mini canyons that form when there's a rain event. And they start getting bigger and bigger and make that slope much more unstable. So this was last week. And some of that material is actually pretty close to the shoreline now. Some of this fill material has made it within where large waves and swells will reach. So when we have a big wave event, that material is now going into the water column, maybe on the reef. And here's some of those rills and gullies that are forming. And this thing's slowly eroding and collapsing. Again, a very steep slope. These were my second chance students, and the organoponics farm guys came out to help me do some measurements. Right now, just the bottom of it is if we had a hurricane, a large volume of that would wash onto the reef, and and would cover up the corals and could cause some damage. I think one of the previous speakers talked about that coral bleaching can be caused sometimes by heavy sedimentation rates. The corals can't photosynthesize if they're covered up with sediments. And although there are some critters, we saw, what was her name? I forgot her name. The lady with the... she talked about how... No, actually, it was Seabird talked about how some crabs do remove sediments from the corals and can clean them off. But corals are adapted to a certain sediment load, and if you put more of that on there, there can be some serious problems. So one of the things that soil texture, when we're talking about turbidity or when it gets in the water column, is looking at time required to settle 1 meter of sand. And for the samples we're looking at are, again, hours to days for this stuff. So if a large volume of this gets on the reef, it's going to take days to settle out. Even if there's a big current, that would help, but some of it will still stay there. There's been some research done on sediments due to reefs. This was one in Asia. They set up some monitoring that collects sediments over time. They look at the corals over long periods of time, take slices of them, see how they've affected. This was 1-day exposure, 2-day exposure, 3-day exposure to high sediment volumes. And there's been several papers out on the damage exposed to sedimentation to coral reefs. So it's usually not good, although they do say corals are usually adjusted to a certain sediment load in a certain area. And I just put this up there because I wanted to say, mention, this is from one of the papers, sediment composition also plays a significant role in the damage to coral tissues. And if you have more damage with decreasing grain size. So the small particles in that fill are more dangerous to the corals than regular sand. All right, so I did these 2 reports, 2011, 2012. 2012, also the dive operators wrote a letter to the island government. We're trying to make them aware of this problem and that we're very worried about it because of the dive sites. This summer, I worked with some Dutch consultants that came here. In the Orchid Talk, Kai Wolf talked about some projects that the Dutch government is funding on the island of Saba for nature conservation. And this is one of the 3 projects that's been submitted and will most likely be funded. So, next slide. The synopsis is pretty much what I had put in my previous reports. The dumped sediments are much smaller size than natural beach sands of Saba. They have a high porosity, and on the steep slopes, the landslides are inevitable. Wave erosion will cut in and cause even more landslides, and then because of those particle sizes, they remain suspended in the water column for a long duration and will settle on the reefs and could cause damage to the reefs nearby. So the project plan is, the partners on this project to remediate this problem on Saba is the Island Government of Saba and the Saba Conservation Foundation. And so we want to eliminate the threat from that dumped debris and move it somewhere else. They have picked a location, which is, as far as I know, the final location. And as soon as the grant money is approved, this project will start. So I'm hoping that it will start in January officially when I come back. Next slide. All right, so here's where the dump material is, that 3,000 truckloads of sediment. What the consultants came up with is that we move the majority of it, maybe leave some of it there, but put it at a higher elevation back a little bit further down on up on the hillside. So there'll be a massive moving event, so another 3,000 truckloads of moving. And then what we did this week was start the surveying process. So we don't know, everybody says it's about 3,000 truckloads, but what's the volume there? So again, I went out with the Second Chance kids and the Organiponics Farms guys to try to get some idea and make some measurements of what's happening. And this is the tool I use to measure slope. I use it for some of my other surveys. But basically, it's a 1 meter wide A-frame with a digital level on it. And so we measure every 1 meter and we can get the slope of what we're looking at. And it looks a lot easier than it was. Who was there? I thought I was going to slide down this hill. It is very steep.
It doesn't look easy.
It doesn't look easy. And everything's kind of rolling with you. I thought someone was going to take a tumble, but no one did. We were all pretty good. So we measured every 10 meters along this slope. And it was, we had 16 transects. It's about 160 meters long. And measured all the way down so I can get a volume idea of what's going on. Next slide. The local guys got a little hot, so they had to take a break under a rock, cool off. And they pretended they were goats. They were very good at imitating goats. Got some help from Latoya. All right, so one of the things when you're looking, so we know where we're placing it. We'll have to work with the design of how it's placed. One of the things that we look at is runoff impact. So we move the sediment and it's going to rain and some of that will run off back towards the shore, but there's a lot of things we can do. If it's uncontrolled, you're going to get sedimentation rates that are huge, which is what we have now. But if you account for erosion and sediment, you can minimize those, and I'll talk about a couple of the ways you can minimize that. So there's several guides out there. I've consulted all the ones in the US, which are pretty good. There's not too many for tropical areas, but USVI has done some nice ones. How do you control sediment erosion? So one of the things is once we move it to put plants in, the plants absorb the energy of the falling rain, so the sediment doesn't move so much. The roots hold soil particles in place and help absorb more water in that soil. There's other things that we can do, and we're still working out exactly what's going to happen. But instead of just making this nice straight slope, you want to grade it and make it kind of chunky so things can grow in there and things don't flow smoothly downhill. You don't, again, want a straight slope. You want to maybe have some staircases down. And the other thing you probably should do is have a low area of slope so the water will collect here, and then a little high area is a buffer so that all that sediment's not washing right onto the beach. Again, when you have that flow, you don't want it to go straight downhill. You want to have some places that are catching some of that sediment. We talked about putting up some fencing material. We're not sure until we get it moved exactly what it's going to look like. Other things you can do are plant trees and other types of vegetation, and there's a lot of different designs. There's temporary measures, more long-term measures that we're looking into. And this was really nice that the Organiponics Farms guys came down with us, because I'm now collaborating with Otto about what are some native plants that we can use in this area. And again, you may want to do your plants and make some kind of gabions or some kind of rock wall to hold any sediment that's coming down from where you place the new fill. Different types of sediment. Again, we're looking at silt and clay types things are fair to good. Not everything will grow in this soil. Only certain things will grow. It's a very dry area, so we have to look at what types of things we're going to plant there. Then there are certain ways to plant shoots. Again, working with Otto on this to do some cuttings. We think it would be nice to have some sea grapes down there. We're looking for some other indigenous plants. And how do you place them and how do you make them grow?
How do you keep the goats away?
Well, I don't think the goats eat sea grape. Yeah, we're looking also at the plants that goats don't eat. So there's certain ways to place these. How is that going to work? As we're moving the sediment, we're going to be thinking about how to make certain things like this. And when we were out in the field, we did look at the existing vegetation that's there, and this is a marum bush, which is, any local Sabans know what medicinal purposes this bush serves? Yeah, if you get a cut or a scratch, you can squeeze the leaves of this on your cut, and they say it heals a lot faster. But this is, and it's also very odoriferous. It smells really nice. If you crumple it, it almost smells like basil or something. I don't know if they use it in cooking. Marum? So we're looking at the native plants. These are some little tiny plants that are growing there. We still don't know what they all are. We have yet to identify them. Just seeing how big they are, the type of area they take up. I call this goat rose, a kind of a periwinkle. The goats do not eat this. This is a prickly plant. Anybody? I don't know what this one is either, but it's not one you want to pick up. It has big spines on it. But it also grows in very poor soil and very dry areas. This is one I've just seen taking over small areas. It's almost like a grass that we're going to look into. There's several grasses there, so one of the things we're wondering is, before they dig up all the material that grasses started growing on, should we pick up those grass plants and transplant them somewhere else and then put them on the new fill when it's moved? So we're looking at types of grasses. This is the indigo plant that they make the blue dye from. It also grows very well in this area. This is one of the grasses. They don't have very deep roots, but they do hold the topsoil down, so this would prevent immediate erosion from rainfall. So we want to try to get some of these grasses transplanted. So again, we'll have to house them temporarily somewhere before they bulldoze and then put them back. And I'm going to end with what can you do to help. I know a lot of people have talked to me personally about this issue. It's very upsetting. What's going to happen? How are we going to deal with it? Well, it's in the works to remediate this problem. What you can do to help is come to talks like this, find out what's going on. I think as soon as we start figuring out what's going on with the plants, Otto and I are going to need lots of people to help grow some of these little babies somewhere in pots and maybe in your backyards or something. So we're going to work on that. And I just wanted to emphasize that you never really know what you have until it's gone. And tent reef could be gone fairly quickly if we don't get this problem figured out. All right, two other things before I finish up. Report on Wells Bay Beach, because I know everybody loves this beach, the one real natural sandy beach on the island. The last time I could measure this beach was the first time I did Sea&Learn in 2005. And so these guys are much older than they look here. Do you guys know who these people are? Yeah. And so it was 2005. The last time I was here when there was a beach, then the beach disappeared, at least for the last 3 years. I haven't been able to go out and measure it, but we got to go out there this week to measure it. And this was one of my Sea&Learn field projects, and my crew of Imka, Jeff, Marie, and Nina came on the dive. Nina was on this. The three of them helped me do the survey, so there's nice sand here, there's cobbles in the back. We found a hole on the beach, and it almost looked like where a turtle comes to nest, but it could have just been a dog or something dug the hole. So I dug in there to see if there's some eggs or anything, but I immediately hit cobbles. So within 2 feet underneath the existing sand is more cobbles. So underneath the sandy beach is the rocky beach. When the big swells and waves come in, like they're starting to come in now, that sand is going to disappear again. So again, this beach goes back and forth naturally depending on the size of the waves. And then the other thing I talked about last year is the beach is not just the material on the shore, it actually goes offshore. Technically speaking, a beach is that volume of sediment that goes into much deeper water, and usually about 30 feet deep is the material that is interacting with the land beach. So we went out there with the Yelp students who are learning to dive through Saba, and they helped me do some underwater measurements of the underwater beach. With Caroline. And then we also did a field trip with adults. Again, Marie, Jeff, and Nina, sorry, came out to help, and we did another set of measurements. And usually, and what I did with the kids is I usually do one profile in the middle, but with my adult helpers, we also did 2 on either side. so I'll get a much better idea of what's going on. And I just worked up, I think the next slide's the data. Oh, so the first time I did this was August 5th, 2011. So here, this is just underwater. The beach wasn't here, so we started about 5 feet deep, and we went out 250 meters offshore. So you can see it slopes gently, surely but slowly offshore. And all this material is what supplies the Wells Bay beach with sand. So this is a slide I showed last year. This was that 2011, so it's still really confusing me. I'm not really sure what's happening. But about 100 meters out, they're all similar. And then after that, in 2007, we had 4 meters higher of sand offshore. And all the ones we're doing now, you'll see even the ones from this year, we're still missing this big chunk of sand offshore. And I don't know why it was there and we didn't have a beach, and now we have a beach. Next slide will show you, no, go back, sorry. These were the 2 we did this week. And we're losing more and more sand offshore, but we still have a beach near shore. So this problem is still interesting. We don't know what causes it. Trying to monitor the resources in that area. Next slide. The way you can help is by posting on this Facebook page. So anytime you take a picture, whether it's there or not, I'm trying to have a visual record of what's going on with this beach. I know the people who find, when it finally comes back, the people who find it don't tell anybody for a while so they can have the beach to themselves. But, you know, send me a quick note, because I don't find out till like a month afterwards, and I can't see what storm events or what swell events or something were happening. So, quick drink. So please, you can, you don't have to tell everybody the beach is there, but send me a little note and tell me the beach is there, so I know when it arrives or when it disappears. You can give me a heads up if you go down there frequently to let me know what's going on. And the last thing I want to talk about is quickly the mapping that I've done this summer. Does this map look familiar to anybody? Anybody seen this map before? A couple people. This is a map I made many years ago of Saba underwater seamount, and this was made with just a depth gauge and memory and pen and ink. Okay, it was a pretty good map. I think everybody agrees it was a decent map. But this summer, next slide. I went out with Captain Charles in the Saba Marine Park, and we have a GPS on the boat with a sonar on it, and basically we mow the lawn. It's like mowing a lawn. You go back and forth and try to get as good a pattern as you can get. So this was in, now I forget what this is. I think this is Ladder Bay. Is this? Yeah, this is Ladder Bay, because I remember we had some mooring things going on here. So we go sideways to get the depths, and then we go back and forth to get some depths as well. And then for each one of those points, I can make a map. Next slide. So this is what the new map of the pinnacles look like. It's a draft map. I haven't finished it. Yeah. So I've put, given each dive shop a copy of the old map and the new map, but I'll pass them around if you guys want to look at them. Next slide. And then I just wrote a little report on some of this research for the Dutch Caribbean Nature Alliance, just talking about the Saba seamount maps over time and kind of mapping technology, basically from hand-drawn to, this was some Dutch Navy data, but it was at 10-meter intervals, and now I can get down to less than a foot with the software that I'm using to do this mapping. So I'm passing, and feel free to keep these if you want, passing some of these out, maybe this is what I'll talk about next year more in depth. And then there's a related software program, so I can see that we can see this stuff in 3D. So this is Ladder Bay, showing you the dive sites in Ladder Bay, although I'm not still sure about the GPS coordinates, we gotta figure that out. So looking at Ladder Bay, looking at that, and this is the 3D of the pinnacles, or not including Mount Michel. So that's the main seamount, and here's Mount Michel, and there's a couple other guys sitting out there. I don't know if anybody's gone deep enough to see those. All right, so thank you very much. Think about your oceans, think about your coast. Lots and lots of people are helping me with my work. I get volunteers from all over the place. Thank you everybody, every dive shop, interns. Everybody's been wonderful working on the projects that I've been working on and offshore. So thank you very much.
Any questions for Jennifer?
Yeah.
How do you prevent the government of Saba from doing this somewhere else? Is there any way to educate them that they need to do some sort of environmental impact so it doesn't happen again?
That's a good question. I'm doing my best. The question was, how do we get the government to not do this again? And part of it's education. So I think they're aware now that we've complained so much about it. I can't guarantee that we'll make any permanent changes, but I think the more they learn about how hazard it is to the local life on the coast as well as offshore, that they'll be thinking this more and more as they consider issues that they're dealing with the coast and dumping. Lynn?
I think they might have learned an expensive lesson, and it might have been cheaper to do it right the first time than to fix it after the fact.
Yeah, this is not a cheap project to remediate. Otto?
Our other part of the area, of the island, is happened, I think. There's erosion.
Yeah, there's always erosion everywhere, but the problem is that particular sediment type. I mean, you see all the hill slopes eroding all the time, and when it rains, you can see some of that right offshore, but that seems to dissipate pretty quickly. Tom Van Hoff did some studies in the 80s and found that sedimentation wasn't really a problem, that it clears out pretty fast naturally, but that was the natural sediment. It wasn't this large, big volume of sediment that could be dumped on the reef in a big storm.
My question is, after this point, what is another point more risk or more, difficult for the erosion affect the coral on the place? After this?
I'm not sure what you're asking, Otto.
Which place will be next?
Oh, which place we're next? Where they're moving it, or where?
No, around the North Coast Trail,
Oh.
are more areas which discard the risk. Like this.
I think so. I just did the North Coast Trail. Sometimes the sediment is good. Like if you look at Cave of Rum Bay, there's always a beach there. There's lots of erosion going on uphill, but there's no reefs right offshore. So and it's also this bigger grain size, so it forms a natural sandy beach, and a lot of it isn't suspended in the sediment column. It'll be taken offshore and settle out pretty quickly. So normally the sediment of Saba aren't these fine particles, but they've just taken a big chunk of this clay-like material and loosen it up so it's ready to go offshore. That would naturally happen over thousands of years. That stuff would be eroded, but it's the volume and the velocity that could reach the reef that would be hazardous. Yeah.
Is this a case of doing something different in the third world area as opposed to what we would do back home? For instance, all of us are very familiar that back home environmental impact studies must be done before any major change. Is this just neglect, or was an environmental impact done that just wasn't adequate?
I'm not sure the exact procedures on Saba, but I'm not going to comment. I don't want to go into that. But
I need a short geological lesson. This is a volcanic island. It's all ash. There isn't that much organic material, I don't think, to make that much clay. Where does all that clay come from?
That was a particular event that did have some clay material in it. I'm not a volcanologist either, so I'm not sure how that exactly happened. But you can see that there's some when you go around to the airport. You can see that, or when you're landing, you can sometimes also see some of that really orange clay material. So there are deposits around the island, but I'm not sure exactly how they're formed.
Thanks.
And they don't crumble, they're almost rock, but they've loosened this up into soil now, which is the reason why it's hazardous.
I'm curious about the placement for the new tent reef debris. I noticed in your picture that the dominant current most of the time is going to be to the west. But then I saw another arrow down below pushing the other way, which made me wonder, is there going to be washback? Is it possible that if at some point this does erode despite all the
Right, this is not the perfect location. This was the location chosen, okay? So there were other locations that I thought would be better, but they were cost prohibitive, like bringing it off the coast and dumping it somewhere higher. Yes, the weird thing, I don't know if you can go back to any of my slides. So the current at 10, if this is 10, the main current goes this way, right, everybody? Except when it reverses every now and then. But the current wraps around the island, and there's actually a current that comes around from Ladder Bay. And as I'm studying the beaches there, some of the research area is affected by this current that's going this way, but most of it's going that way. So there is a possibility, depending on hydrodynamics, that could happen, that it could bring the sediment back on the reef. And it would just depend on the wave regime and where the predominant swells were coming, what direction the hurricane was coming. So that's the problem. It could have very little effect or could be disastrous. We just don't know. Yeah, Susan?
Yeah. How long do you think it would take to reverse engineer this, get the 3,000 dumpfuls up in another location? What's your time frame for completing the
The
project?
time frame is 7 months.
This time, and we were really lucky.
Yeah, we lucked out the last 2 years with not being hit by a hurricane. They were trying to get this process before hurricane season, but that just didn't happen. It would have been nice, well, although I think maybe it was better that they didn't move it quite yet. So the perfect time to move it is in the spring after hurricane season to prepare and get everything planted and get that vegetation stabilized for the next hurricane season. Yes?
I'd like to suggest that in terms of populating with vegetation, perhaps if a marijuana plant was established, that might encourage a lot of people to help out
In growing things?
Yeah.
Yeah, they do plan on rehabilitating the whole area and making it a recreational area, so some nice plants. There is a really nice beach around the corner, really small pebbles that you can walk on. There's some really nice snorkeling there, so I think the ultimate goal is to have this an area where people can walk their dogs, go for a little walk, a little run, hang out on the beach, do some snorkeling, so they are trying to make this a nice area when it's finally said and done. Okay.